We now discuss the solution of a problem from the section Differential Calculus, and the problem is on the Rolle's theorem. This question has appeared in Joint Entrance Examination Main held on 27th July 2021 in the second shift. The problem is, let f be a twice differentiable function from the open interval a comma b into the set of real numbers such that f of x is equal to integral a to x g of t dt for a differentiable function g of x. If f of x is equal to 0 has exactly 5 distinct roots in the open interval a comma b, then g of x multiplied by g prime x is equal to 0 has at least, we are given 4 options. Option 1, 12 roots in the open interval a comma b. Option 2, 7 roots in the open interval a comma b. Option 3, 5 roots in the open interval a comma b. And option 4, 3 roots in the open interval a comma b. We are given a real valued function defined on the open interval a comma b, and it is given that it is a twice differentiable function, and f of x is defined as integral a to x g of t dt, where g of t is a differentiable function. If f of x is equal to 0 has exactly 5 distinct roots in the interval, open interval a comma b, then we have to find how many roots are there for this equation g of x multiplied by g prime x is equal to 0. We now discuss the solution of this problem in detail. We first review the Rolle's theorem. Because we use the Rolle's theorem, let us first of all be familiar with the Rolle's theorem. If a real valued function f is continuous on the closed and bounded interval a comma b, differentiable on the open interval a comma b, and f of a is equal to f of b, then there exists at least a point c belongs to the open interval a comma b such that f prime c is equal to 0. This is a very well known result. We have been using quite a good number of times. And we also recall Leibniz theorem for the differentiation. Let phi of x and psi of x be differentiable functions on the closed and bounded interval alpha comma beta, and if f of t is continuous on the closed and bounded interval phi of alpha comma phi of beta, then d by dx of the integral from phi of x to psi of x of f of t dt is equal to f of the upper function psi of x multiplied by the derivative of upper function psi prime x minus f of the lower function phi of x into the derivative of the lower function. So the derivative d by dx of the integral phi of x to psi of x f of t dt is equal to f of psi of x, the upper one, multiplied by the derivative of the upper psi prime x minus f of the lower function phi of x multiplied by its derivative phi prime x. And it is a very important theorem. And we also use a very well known result A we call it, and that is, let f be a real valued function defined on the interval, open interval a comma b, and it is a twice differentiable function. If the equation f of x is equal to 0 has n distinct roots in the open interval a comma b, then the equation f prime x is equal to 0 for the first derivative has at least n minus 1 distinct roots in the interval a comma b, and the equation f double prime x is equal to 0 has at least n minus 2 distinct roots in the open interval a comma b. So if f of x is equal to 0, this equation has n distinct roots in this interval, then its equation f prime x is equal to 0 has at least n minus 1, and the equation f double prime x is equal to 0 has at least n minus 2 distinct roots in the interval a comma b. The proof of this is easy using the Rolle's theorem. And if you want the detailed proof of this result A, and for that you have to see the next video. But we will use this result in this example. Now let's get into the example first. This is our example. And let's discuss the solution. We have f, a function from the open interval a comma b to r, that is f is a real valued function defined on the open interval a comma b, and it is given f is a twice differentiable function. Given f of x is equal to integral a to x g of t dt, where g of x is a differentiable function. Now, if you want its derivative f prime x, and to get the f prime x, we will use the Leibniz theorem here. The lower one is phi of x, the upper one is psi of x g of t dt. Then f prime x is equal to the upper one psi of x g of psi of x into the derivative of psi of x minus g of the lower one phi of x into the derivative of it, that is f prime x. So psi of x is x, phi of x is given to be a constant a. So by Leibniz theorem, g of x multiplied by the derivative of x minus g of a, the lower one, multiplied by its derivative, the derivative of the constant is 0, and that is equal to g of x. So this is using Leibniz theorem, we will get f prime x is equal to g of x. So you can differentiate once more, and that is f double prime x is equal to g prime x. Agreed. And what is that we want to find? We want to find how many roots are there for g of x into g prime x is equal to 0. Now g of x into g prime x is equal to f prime x into f double prime x. Now we are given f of x is equal to 0 has exactly 5 distinct roots in the interval a to b. We now use that result A. If f of x is equal to 0 has n distinct roots, then f prime x has n minus 1 distinct roots, and f double prime x has n minus 2 distinct roots in the interval a to b. Now f of x is equal to 0 has 5 distinct roots in the interval a comma b. Use that result. The equation f prime x is equal to 0 has at least 4 distinct roots in that interval, open interval a comma b, and its second derivative, and the equation f double prime x is equal to 0 has at least 3 distinct roots in the interval a to b. And to discuss about how many roots are there in the interval a to b, for this equation g of x into g prime x is equal to 0, and that is we have to discuss how many roots are there for the equation f prime x into f double prime x. So therefore the equation f prime x multiplied by f double prime x is equal to 0 has at least 4 plus 3, that is 7 roots in the interval a to b. Now the equation g of x into g prime x is equal to 0 is same as the equation f prime x into f double prime x, and the equation f prime x into f double prime x has at least 7 roots in the interval a to b. Therefore the equation g of x into g prime x is equal to 0 has at least 7 roots in the interval a to b. Let's look at our options. Our answer that this equation has at least 7 roots in the interval a to b appears against the option 2. Therefore, our answer is option 2. That is the detailed discussion of the solution of the problem from differential calculus, and the problem is based on the Rolle's theorem, and I am sure that you have understood the solution of this problem, and go on working out some more problems on the applications of Rolle's theorem. Thank you.